said in the previous videos, what is really lacking for students is connecting the equation to the graph. And so without that visual connection, we're not going to fully understand what we're doing, and you can't teach this concept for the first time and not show someone how the graph reacts. So this is also a good pedagogy moment, because pedagogically, I have my students make the graph of every single question every single time until they can literally visualize the graph in their head. And so that's a big key component that's missing in our algebra education. So in the previous videos, we've talked about a circle, and when I'm dealing with a circle, I have an x squared and a y squared. They have to be added together, and it has to equal some number. For an ellipse, I would have the same equation, but I would have x squared and y squared divided by something. So that's what differentiates an ellipse from a circle, is the x and the y squared are divided by numbers. A hyperbola is differentiated because it has subtraction. So we still have a denominator for most of these, but we have subtraction, which is what generates the difference in an ellipse and a hyperbola. So I'm going to kind of start off with this unit 1. So here, you'll notice a hyperbola is a non-connected conic section. So I don't have a circular motion. I'm going to have literally, it looks like two parabolas that are facing away from each other. And so let's see how these things correspond. So I'll look at my x-axis and I see -4 and +4 on my x-axis. And if I look at this ellipse, that -4 and that +4 is being impacted by this, and the square root of 16 is 4. So the way you get an ellipse is you're going to basically take the largest number, which would be the non-negative number, and if you take the square root of it, that's going to be where your hyperbola falls. And you're going to draw your lines through your hyperbola at those points. Now, let's look at the difference if I make that x negative. So again, this is an ellipse because somebody's not negative. The minute I make somebody negative, now the 9 is the larger number, and you'll notice it's at 3 and it's at -3. You're also going to notice there's like this really nice diagonal symmetry. So in a hyperbola, I can actually fold my paper and see symmetry if I folded it from the vertical. So if I imagine folding it directly on the axis, then you would be able to see that it's very symmetrical, similar to the ellipse and to the circle. Now, just like the ellipse, as I start moving things around, I'm going to notice patterns. So here I have, let me get my original one up here. So my green is my original and my red is my shift. So I was at 3, and now I'm hanging out over here at 2, 3. And so what's the difference from 0, 3 to 2, 3? I moved it by 2 units to the right. So subtraction, like we saw in the other conic sections, moves us to the right. If I want to add, it's going to move me to the left by 2 units. Now again, I have to draw the hyperbola, this base hyperbola, before I can actually shift anything. It's really, even for math teachers, it takes a long time for us to get to this actual shifted piece. And really with your students, I wouldn't ever suggest not showing the step of here's the original hyperbola, here's the moved hyperbola. It's just taking too much of a leap in cognitive support there. So that's definitely how I would suggest doing it. And so again, let's check our y's out. So now let's do the same thing to the y-axis and let's subtract and see what happens. So again, red is my shift and green is my original. So if I look, by subtracting 2, I actually moved it up 2. So again, I'm seeing that interesting and that unique. I'm moving in opposite directions. If I add 2, I'm going to move it down 2. And so this is kind of a look at how to connect the equation to what you're seeing on the screen, and then how to shift that graph so you can find things that you need to find in that graph. Now, I'll also make a video on things like the major and the minor axis, but this is really just giving you the foundational information of, is it a circle, an ellipse, or a hyperbola? And then once you do that and you get a feel for what these graphs look like, then you can move on to understanding major and minor axes and things like that.